All right, solving systems using inverse matrices. So your goal out of this section is to learn how to solve systems of equations using matrices. Just remember the essential question while you're going through this video and doing your homework. Homework is number 45 through 52 in the homework packet. All right, so we want to find the indicated matrix. We want to multiply the first matrix by the second. So we have to check and make sure that it's possible. So 2 by 2 times a 2 by 1. The middle two terms are equal, so our resulting matrix will be a 2 by 1. We always look, that's the first and that's the second number in the product. All right, so let's go ahead and multiply them together. So 2 times x is 2x plus 4 times y. Second row, 6 times x plus 3y. So we're multiplying the first row times the first column, second row times the first column, and that's our resulting matrix. All right, let's go ahead and do the same thing, same type of problem. You can multiply them together. So we take negative 2x minus 6y. 4x minus 3y. Same type of problem as example 1. I just multiplied the first row times the first column, second row times the second column, and that is our resulting matrix of 2 by 1. All right, write the system using matrices. So what we have to look for is, sorry about that. First of all, to write the first matrix, we use the numbers on the left side of the equal sign in front of whatever in front of the variables, the coefficient. So they call this the coefficient matrix. Okay, so this is the coefficient matrix. So it's 12, it's coefficient of x, negative 7 is coefficient of y, negative 2, and 6. Okay, the x and y go here. This is called the variable matrix. And last is equal to 9 and 4, and they call this the constant matrix. It's important that you understand the words that we're talking about and what you're reading in the packets so you can answer the questions. All right, let's do this example. So you can try it yourself. You can stop it right now and I'll continue. Then you can check your answer. Okay, negative 5, 2, 13, negative 8, x, y, 16, 5. So I hope you stopped it so you can try it yourself. This is what the result is when you're writing out a system of equations in matrix form. All right, so we're going to find the inverse of the coefficient matrix. Because that's to solve this system using matrices, we first have to find the inverse. Then we're going to multiply the inverse of A multiplied by the constant matrix. So again, we have 5, 24, 1, and 5. Remember, if it's just x by itself or y by itself, there's a 1 in front of the variable. All right, so first of all, we have to find out if it does exist, if an inverse does exist. So we have to find the determinant of A. So 5 times 5, 25. 24 times 1 is 24. So it does equal 1. So the determinant does exist. So A inverse, just to recall, A inverse is equal to 1 over the determinant of A. Then we switched D and A, and B stays in the same spot, and C, but they change signs. So in our case, we have 1 over the determinant 1 times 5 and 5 are the same, but they're switching spots. Negative 24 is changing the sign, and so is negative 1, but they're staying in the same spots. So to finalize this, A inverse, we just take 1 times 5 is 5. 1 times negative 24 is negative 24. 1 times negative 1 is negative 1. 1 times 5 is 5. So that's the inverse of A. If we multiplied A times A inverse, we would get the identity. And if you can do it quickly, that's a good way to check to make sure you got the right answer. All right, so solving systems of equations using inverse matrices. First step is to rewrite the system using matrices, which we've already done. Second step is to find the inverse coefficient matrix A inverse, which we just finished up doing. And then we're going to multiply the inverse matrix A inverse times the constant matrix, and that will give us what x and y are equal to. So in this system, we have 2x plus 7y equals negative 3. 3x minus 8y is equal to negative 23. So the first step is we have to rewrite it in matrix form. Again, we have the coefficient matrix times the variable matrix equals the constant matrix. So they put them in that form. So we have to find the inverse of the coefficient matrix. Remember, the first thing to do before you find the coefficient, the matrix inverse of the coefficient matrix, find the determinant. So we have negative 16 minus 21 is equal to negative 37. If the determinant equals 0, then the inverse does not exist, so you couldn't find the answer to this problem. Be no solution. But it does exist, so the inverse is 1 over negative 37 times the 2 by 2 matrix, negative 8, negative 7, negative 3, 2. Remember, they switch spots, negative 8 and 2, negative 8 and 2 switch spots, negative 7, negative 3 change signs. Do not multiply the scalar. This is the scalar in front of the matrix. Do not multiply it through yet until you finalize it by multiplying the constant first. Then you multiply the scalar last. Scalar is always last. So as you can see, we have A inverse times B. So when they multiplied the two matrices together first, negative 8 times negative 3, I should have put in parentheses, I don't know why they didn't, but plus negative 7 times negative 23, which is 185, and then negative 3 times negative 3 plus 2 times negative 23 is negative 37, and we solved it and got negative 5, 1. So therefore, the solution is x negative 5, 1. So let's go and do an example. All right, so we have to solve the system of equations. They've already taken care of step 1 for us. They put it in the matrix formula. So what's the coefficient? Well, the coefficient is 2, negative 3, 1, and 1. Is there a determinant? Let's make sure. Determinant of A is equal to 2. 2 times 1 is 2, minus negative 3 times 1 is negative 3. So the determinant is 5. So we found that the inverse is 5. So we'll put that 1 over A inverse is equal to 1/5 times the 1 and 2 switch places. Negative 3 changes to positive 3, and positive 1 changes to negative 3. So that is the inverse of A. So what we have is 1. So A inverse is 1/5 times 1, 3, negative 1, 2, times the constant, which is 1, 3. Constant matrix. Remember, do not multiply that scalar through yet. So let's go ahead and take a look. So if we we have 1/5. Okay. So we're going to take 1 times 1 plus 3 times 3, negative 1 times 1 plus 2 times 3. Remember, we're only going to have a 2 by 1 matrix at the end because we're just trying to find x and y. So let's bring this up here just for sake. So we have 1/5. 1 plus 9 is 10. 6 minus 1 is 5. So it equals 10 divided by 5 is 2. 5 divided by 5 is 1. So our solution is 2, 1. So the key is do not multiply by the scalar until the last multiplication. 10 divided by 5 is 2. 5 divided by 5 is 1. Okay, let's look at another example. All right, so example 7, we're going to go ahead and solve the matrix. They've already put it in place for you. We just have to find A first. So A is -1, -1, 2, and 5. The determinant of A, let's see if it exists, is equal to -1 times 5 minus -1 times 2, -5 plus 2 is -3. Right? So the determinant does exist. So now we just have to find A inverse, which is 1 over -3. 5 and -1 switch places. -1 turns into +1. 2 turns into -2. So now we have the inverse. So now we have, you can say -1/3 times 5, 1, -2, -1 times the constant, which is 8 and -31. All you have to do is follow the steps. They wrote it in for us already in the matrix form. We have to identify the determinant of A. Once we do that, we find A inverse. Then we take A inverse times the constant term, which is 1/3. Do not multiply that scalar until the very end. 5 times 8 plus 1 times -31. And we have -2 times 8 plus -1 times -31. Okay. So we have 1/3 times, so 40 minus 31 is 9. And then we have 31, right? This is 31 minus 16 is 15. So 9 divided by a -3 is -3. And then 15 divided by -3 is -5. So our solution set is -3, 5. All right, I'm going to give you example 8 to do on your own, example 9 to do on your own, and then I will do example 10. I'm running out of time, so this is part 1 of 4.4, and I will start example 10 on part 2 of 4.4. If you need the answers to examples 8 and 9, just come to me and I'll give them to you once you're completed them. Thank you.